This is Unit 9, Lesson 4, Law of Sines. There are two laws that we use when we are solving triangles that are not right triangles. And one of them is the law of cosines, which is in Lesson 3, and the law of sines, which is in today's lesson. Law of sines is a lot simpler than law of cosines, I believe personally, because the formula for that is so much easier. The law of sines simply says that the ratio of sine over the sine of an angle over its opposite side is equal to the sine of another angle over its opposite side, which is also equal to the sine of an angle over its opposite side. So we're going to use those opposite sides again in this lesson, but we're just going to set up ratios instead of having to use a long formula and plug everything into that formula. So the biggest part is going to be identifying your opposite sides. So when you're looking at angle A, you need to remember that the opposite of angle A would be this side over here, which is side A. It's labeled for you. And the opposite of angle C, once again, be to the other side of the triangle and would be side C. And opposite of side B, or angle B, would be side B. So we're going to be using some problems that have the A, B, and C. Most importantly, we're going to be looking for those opposite angles and sides and setting that up. So in the first problem, it says find all of the unknown angle measures and side lengths. So we want to start by organizing our information, knowing what angles we have, what side lengths we have, and go ahead and determine what our opposites are. So angle A is opposite side B, and it has a measure of A. So I don't know what the length of BC is, and I don't know what the measure of angle A is yet. Angle B is 28 degrees, and it is opposite AC, which measures 8. And angle C is 42 degrees, and it's opposite BA, and I don't know the length of BA, so we've just put a C there to hold that place. So things we need to know. So these are the things we know. We need to know what is the measure of angle A, and we need to know what is the length of BC, and we also need to know what is the length of AB. So let's start. Because we have two angles, the fastest thing we can do is find angle A. So let's find angle A first. I don't even want you to set up a ratio to do this. You know that the triangle sum theorem says 180 minus the angles that I know will give me the measure of that third angle. So 180 minus 28 minus 42 is 110. So we've already got the measure of angle A right there. And then what we want to do is we want to set up proportions based on what angle we have that already has an opposite. So here's side AC. Side AC measures 8, and its opposite is angle B. So we're going to use these two pieces of information to set up our ratios. So the next one we want to find is we want to find a missing side length. So we have to decide which side length we want to do. If you want to find side A, if you just want to go alphabetically, that's great. In order to do that, you'll have to know the measure of angle A. Well, now you know the measure of angle A. You just did the subtraction. So you could find angle A first, or you could find side A first, or you could find side C first. It's really kind of up to you because you now know all three angles. So let's just go alphabetically, and let's find this A right here first. So we're going to start with this relationship, and we're going to say, so side A is BC, and we're going to do the sine of AC, which is, or not AC, but the sine of angle B, which is 28, over the length of its opposite side, which is 8, is equal to the sine, and we're looking for side A, so we're going to use its opposite angle, which is 110. So the sine of 110 over that A, that side that we don't know. And then all we have to do is solve this proportion. You've been solving proportions for quite a while now. So sine of 28 times A is sine of 28A. And 8 times the sine of 110 is a big long decimal that we're going to round to the nearest hundredth for the moment. And then we want to isolate A. We want A completely by itself. So we're going to divide by the sine of 28. Don't just divide by sine. Don't just divide by 28. divide by the sine of 28. And that's going to leave us with A equals 16.02. So the length of BC is 16.02. The other side that we want to find is we want to find AB. And we're going to start with this same ratio. Just because there's no reason to change it, might as well stick with what you know. Stick with what was given to you in the original problem. So in order to find AB, we're going to start with the sine of 28 over its opposite side, which is 8. And then we want to find this C right here. So that's what we're looking for. That's the side we're looking for. And its opposite angle is 42 degrees. So we're going to do the sine of 42 degrees. And then we're going to do the same thing. We're going to cross multiply and solve. So we're going to end up with the sine of 28 times C equals 5.35. And then we're going to divide by the sine of 28. And we're going to find that that missing side length is 11.4. We're going to round our final answer to the nearest hundredth. In this case, it just rounded to 11.4. And then we want to organize our information so that if someone's trying to find all of our answers, it's pretty simple to do. Angle A was 110 degrees. BA, or AB, same thing, is 11.4. And BC, which was right here, is 16.02. Way, way simpler, in my opinion, than the law of cosines. All right, so in example 2, notice there's a reminder. When you're using a trigonometric ratio to calculate an angle length, you got to use the inverse. Don't forget to use the inverse, and you're going to see that here in just a second. So we look at what we've got. We know that angle A is opposite BC. Here's angle A. It's opposite BC. Don't know the length of BC, so we'll call it A. We know that angle B measures 33 degrees, and it's opposite of AC, which measures 12. And we know that angle C is opposite of BA, and it measures 15. So we have to decide where we want to start. I like to start with the angles. I can't start with the angles. I only know one angle. And so I don't really want to start with angles. I want to start with side lengths. So let's go ahead. Can I start with a side length? Do I have enough information to find this missing side? When I set the law of sines up, I say the sine of an angle over its opposite side. Well, if I want to find the measure of angle B or side BC, I'm going to have the sine of angle A. Do I know the measure of angle A? No, I don't. So I have to go back and calculate the measure of the angles before I can calculate the measure of the sides. Now, I have to decide which angle I want to do first. If I want to find the measure of angle A, I need to be able to compare it to its side length because, once again, I have to make the comparison between the angle, the sine of the angle, and its opposite side. So I can't start with angle A because I don't know the length of this side. So I kind of get trapped and stuck, and I have to start with angle C. You may have to start and stop a few times and erase some things to figure out exactly where you want to start or where you can start depending on the information that you're given. So we're going to have to start with angle C. So we're going to calculate the measure of angle C. And we're going to start with the angle that we know and its opposite side. So we're going to do the sine of 33 over its opposite side is equal to, I don't know the measure of this angle, so I'm going to say the sine of C, it's my missing angle, over the side length, which is 15. And then I'm going to cross multiply, and 33, the sine of 33 times 15 is 8.17. And 12 times the sine of C is just 12 times the sine of C. Now we want to isolate the sine of C. We need it by itself. So we're going to go ahead and we're going to divide And here's where you've got to pay attention to that statement that I read earlier. Remember, when you want to calculate an angle measure, you need to use the inverse. Right now, we have 8.17 over 12 equals the sine of C. That's not how we calculate an angle measure. So we're going to have to change this to say the inverse of sine is 8.17 over 12. And we're going to put that in our calculator because all the tables are already in the calculator. And rounded to the nearest whole degree, the measure of angle C is 43 degrees. Now, once we know the measure of angle C, finding the measure of angle A is really, really simple because angle A is the third angle in the triangle, and we can use the triangle sum theorem, and we could subtract the angles that we know now. And when we subtract those, we find that angle A is 104 degrees. So the last thing we need to do, so we've done the measure of angle A, the measure of angle C, we need to find the length of BC. So we're going to start with the same ratio that we started with before, the sine of 33 over its opposite side of 12. And we're going to set that equal to, and we want to find the length of BC. BC is right here. So its opposite angle is angle A. So that's going to be the sine of 104 over some number we don't know. You can put the A there, you can put the X there. My X's look more like X's and my A's sometimes look like O's. And then we're going to do what we've been doing. We're going to solve. We're going to cross multiply. We're going to say the sine of 33 times X equals, and we're going to go ahead and multiply those things out, and we're going to round to the nearest thousandth, 11.64. Then we're going to divide by the sine of 33. Oops, those mark out. And X will equal 21.37. So make sure you organize your information. So we're going to come up here because this is a nice empty spot. We're going to say angle C is 43 degrees. Angle A is 104 degrees. And the length of BC is 21.37. Make sure that you put all of the information, all that missing information, together in one location so that it can be found easily. So example 3 has triangle PQR, and we need to identify the information that we have and figure out what it is we want to calculate, what it is we need to figure out. So angle Q measures 39 degrees, and its opposite side is PR, which measures 28. Angle P, we don't know the measure of that yet, and its opposite side is QR, and we don't know the measure of that either. And angle R, we don't have a measure for that, but we do know that its opposite side is PQ. So the first thing we're going to want to do is we're going to want to find, I can't speak all of a sudden, want to find some missing angles so that we can find that missing side. Because remember, you've got to have opposite sides and opposite angles in order to calculate anything that we're looking for. So let's start with R, because we want to start with R because we know Q and its opposite. We can't start with P because we don't know P and we don't know its opposite. But we can calculate R because we do know R's opposite side. So we're going to start with what we know, which is the sine of 39 over 28. And that's going to be equal to the sine of angle R over 41. And we're going to cross multiply. And we're going to get 25.8 equals 28 times the sine of R. And we want to isolate the sine of R, so we're going to divide by that 28. Now, before we can actually do this, we're looking for an angle measure. So we don't want to just divide this and say that that's our angle measure. We actually need to do the inverse of sine. So we're going to do sine to the -1 power and 25.8 over 28. And we will find that the measure of angle R rounds to 67 degrees. And then, rather than make our lives complicated and doing that again to find the measure of angle P, we're going to look for the measure of angle P by using the triangle sum theorem. So we're going to say 180 minus 67 minus 39, and we're going to find that the measure of angle P is 74 degrees. So we can actually go ahead and let's write these in here. This is 67, this is 74. The only thing missing is this side QR. So we're going to find the measure of QR by starting with the same ratio that we started with when we were looking for the measure of angle R. We're going to say the sine of 39 over its opposite side. And then we're going to say the sine, so we're looking for QR. Its opposite angle is 74 degrees, so we're going to do the sine of 74 degrees over that unknown side. And then we'll cross multiply 39, sine of 39 times x equals, and the sine of 74 times 28 is 26.92. And then we'll divide. Remember, when we divide by the entire thing, not just the sine or not just the 39. And when we divide, we find that our missing side measures 48 or 42.8. So let's put all of our information together. The measure of angle R is 67 degrees. The measure of angle P is 74 degrees. And the length of QR is 42.8.